This video is sponsored by Squarespace. So I won't keep you in suspense. The number one rule for storing your astrophotography data is lots of copies keeps stuff safe, which you can remember with the acronym LOCKS with two S's. I did not come up with this. The library at Stanford University did, and I first heard it back in 2012 when I was getting my master's in library science. And one of the big issues in libraries, especially academic libraries, is the preservation and storage of data in an increasingly digital world. And the reason this is a big issue is because data stored on a hard drive will typically be unreadable much faster than data stored on physical media like paper or a book or film. There really is such a thing as bit rot. And over time, the digital data that you have stored as zeros and ones on your drives will either degrade, causing bits to flip from their intended states, which will corrupt your files, or the files will just become unavailable for one reason or another, including just total drive failure. So it's not a question of if that will happen, but a question of when. It might be tomorrow, it might be 30 years from now. Of course, the more time that passes and the more data that you're trying to keep safe, the more that you're going to have to worry about this over time. And the only real defense against this is active management of your data and storing multiple copies of every digital file and photo and video that you actually care about. Locks. And with locks, lots of copies keeps stuff safe. If one hard drive fails or is lost, it's not the end of the world. You have a copy of all that data somewhere else, hopefully in a couple places, another hard drive, one on the cloud, wherever. And then you'd have time to go recover the data that you lost in one place and get a new hard drive, make a new copy, and then make a new backup of that copy. So that's the number one rule, big picture. It's just to stay on top of it and maintaining multiple copies of all the data that you want to keep long term. Of course, the devil is in the details here, and one of the issues is knowing what data is important to keep and what is okay to delete, because we don't need to actually keep everything. And I've learned keeping everything as a strategy, because that was my strategy for a long time, is both expensive and can actually make finding what you need harder, because you're like just sorting through so much stuff that doesn't matter. And I'm laughing because I know this about myself. I'm a bit of a pack rat, both in my physical and my digital worlds, but I do try to get better. I try to stay on top of it a little bit. So, that's another thing we'll get into in this video. What, as an astrophotographer, you really want to keep and what you can safely delete. And I'll not be hiding anything or making it seem like this is super easy. Keeping your digital life organized is an ongoing process. It requires some thought and some active maintenance. I don't think there's any way to do this fully automatic yet, at least. I still struggle with it, and I was a librarian for over 10 years. So there are a number of choices you have to make up front. But I'll say that if you can make those choices, find a system that works for you, and then you can keep to that system, after that, it's going to make your life much easier. But it's a bit of work up here up front if you're currently disorganized. And I'm going to present a lot of information in this video, and you can pick and choose and find the tips that make sense to you and your particular needs, of course. But I think a good structure for this would be to walk through the whole process from beginning to end from an astrophotographer's perspective. So broad picture, we're going to be starting from capturing your raw data on a DSLR or a smart telescope or an ASI Air or whatever it is, to transferring that data off the capture device to some kind of fast storage device like an SSD. And on that fast storage, the data will be processed using Astro software like Serial or PixInsight. Those programs will create lots of what I call intermediary files. And then after you have your finished photo, you need to decide what data you actually keep long term and make backups of, and where to store all of that. And then you need a consistent way to organize all that data in long-term storage with a folder and file naming structure so that you can actually find something when you need it again. All right, so that was the big picture overview for the workflow that we'll cover in much more detail in this video. And as we go through this workflow, I'm going to have more comments about hardware and storage solutions, including this device. This is the Synology DiskStation 1621 Plus, and for full disclosure, this was sent to me by Synology for review, and I get to keep it. Other than the gift of the product, there are no other strings attached with the review. I can say whatever I'd like about this device. As a brief explanation of what this is, it's a NAS, a network attached storage device, which incorporates a hard drive enclosure and a server with some custom software from Synology that makes it easy to set this up and connect it over your home network. And once you get it all set up, you can access it from any computer on your network, and then it shows up as one huge single drive on your computer, which is pretty cool. I'm already familiar with Synology disk stations as I've been happily running a DS920 Plus for several years. So while I just got this one, the DS1621 Plus, a few months ago, I have years of experience in using a Synology disk station in my astrophotography storage workflow. So let's get into that workflow now and start with the actual taking of the photos and where they're stored initially on the field. Like when you're out actually taking the pictures, where are those being stored? And we can split this up into three kinds of cameras. The cameras that have removable storage. This is mostly your DSLRs, your MILC, your mirrorless cameras. The second kind of camera is one with internal storage. And with this, I'm mostly thinking of smart telescopes. And then last are cameras that don't have any internal storage or removable storage. They only have enough buffer to take one image at a time, and then they have to write that image to an attached computer. And most Astro cameras, astronomy cameras, fall into this category. So let's take these use cases one by one, and feel free to skip ahead if you want to skip to the use case that applies to you. So let's start with removable storage, which in 99% of cases is going to mean memory cards. And there are a variety of types of memory cards, with the most common being the full-sized SD card. Probably the second most common is the micro SD card, and then the alternative format that is still around and fairly popular is CF, compact flash. These are the old style CF cards, pretty big, and then these are the new ones, which are actually small, slightly smaller than a full-size SD. For deep sky astrophotography, you absolutely do not need an expensive memory card, because with a traditional deep sky workflow, we don't shoot video, we don't shoot bursts, and so the speed of the card isn't a big factor, and that's what really changes the price of an SD card, is how fast it can write data. So if you shoot ISS transits, or you do planetary imaging, or you're getting an SD card for a total solar eclipse and you want to capture Baily's beads, anything like that where you do shoot video or fast burst mode, then you want a fast card. I'd suggest a V90 card in that case from a reputable brand. My favorite is Sony Tough Cards. But for just regular deep sky, I just use these much cheaper SanDisk cards in big capacities. These days, I like getting them with 256 gigabytes of space per card, and I always have one in the camera and then one in a backup in a card case. And I alternate between those, so it takes quite a while before I have to delete any pictures off an SD card. I don't recommend SD cards as a long-term storage solution. The flash memory they use isn't as reliable as some of the other options we'll talk about later. And what I mean about reliability is, in tests, memory cards will corrupt data more often than other kinds of storage that you would use, like computer hard drives and SSDs. So back to size, you almost certainly don't need 256 gigabytes for one night of shooting. 128 or even 64 gigabytes will probably be plenty, but the bigger cards at slower speeds are not particularly expensive these days. So I'd rather just get the bigger card because, if I'm going on a trip, it's nice to not have to worry about transferring data off to a laptop, and also not to have that sort of anxiety about having enough storage. So, like I said, I like to alternate between 256 gigabyte cards. This card case that I've been showing is really handy. It's my favorite card case. It's made by Freewell. And in addition to being a very tough, hard-sided case with a carabiner, it's also a full USB-C card reader. So if your computer doesn't have a card reader but has USB-C port, this is a really good option for both holding your cards and transferring the data off to the computer. So I'll put the link for this in the description if you're interested. Okay, so anytime I shoot astrophotography, the first thing I do the next day is transfer all my raw photos off the SD card onto the storage device that I'll be using for processing the photos. And this storage device could be an external drive or an internal drive, depending on your setup and how much space you have. And this is a good time to organize your photos as well, so that you're actually transferring them into a folder structure that will make the pre-processing with the Astro software easier. And there are multiple ways to do this, but one way is to download Adobe Bridge, which is free and will let you sort through your photos on the SD card, pull up information called metadata about the files, and this metadata, like shutter speed, will make it easier to know which files are your darks, your bias, your flats, and your lights. And then you can just look through your light frames at this point too. If you want to reject any that have issues like being out of focus, or if clouds came through, or if you're having issues with tracking and you have star trailing, all those kinds of things, you can delete those pictures at this point. You don't have to throw out pictures that have satellite trails, because if you're stacking at least 20 frames, the satellite trails will get rejected automatically through the stacking process, as long as you have something like Sigma clipping rejection turned on when you stack your data. Okay, so the folder structure I use at this part of the process is the name of the object is the top level, the date the data was taken in year, YYYY, MMDD, year, month, day format, and then 4 folders inside there: lights, biases, darks, flats. And this folder structure will work with Cyril's automatic scripts, but it will also work with Cyrillic, Astro Pixel processor, Deep Sky Stacker, PixInsight, whatever you use, this folder structure will still work. Okay, so that's it for transferring and organizing data from a camera with removable storage like a DSLR. Now let's turn to internal storage cameras. And in my case, the ones I have are, I mostly think of the C-Stars, the S30 and the S50. Now, of course, you could argue that ASI 2600 MC Air also counts as an internal storage camera, but sort of all the ZWO stuff have a similar set of issues and way they do the folder and file naming stuff. So if you use any ZWO device, you'll probably get something out of this segment. So it's tempting just to drag the folders off of the C-Star or the ASI Air right to your SSD, and you could do that. But personally, I like to use this opportunity to weed out the JPEG previews, which I won't be using and just take up space and or it can be confusing. So I only transfer the FITS files. And the system I use is the same: the object name, the date the data was taken, and then in there a folder called lights. If you're just using a C-Star, that's all you need, or just the lights. Of course, if you're using an ASI Air, you'd have your calibration folders too. And that's it. It's really just about sorting by kind, only transferring the FITS files. And then I use the same folder structure: object name, date, and then the lights and other calibration folders if you have those. Okay, lastly, let's look at Astro cameras, ones that always need a connected computer of some kind to store the data. If you use something like Nina or SGP, image acquisition software, you'll be able to fully customize your whole folder and file naming structure. So then it really is just set that up once, and then you can just drag and drop off to your SSD. On ASI Air, it's a little bit more like the C-Stars, where you can't fully customize the folder structure, but it does give you some ability to customize the file names at least. But yeah, if I'm using SGP, which is my image acquisition software, I can literally just drag the top level folder, the object name, off of my processing computer right to my SSD. And you may be tempted, if your laptop is what you use for both capture and for processing, to not make any copies of the data. But I think it's a good idea to make copies as soon as possible. I can't tell you how many times I've accidentally deleted data when I've been like sleep deprived. And if I didn't have a backup, I'd be out of luck. So next part of the workflow is processing, and let's talk about what kind of storage device you want for processing your Astro data. You ideally want very fast storage for processing. If you have a desktop PC, one where it's like a tower and you can install anything, I'd install a large, fast M.2 SSD internally. But since many of us are going to be processing on a laptop where the internal fast storage may be pretty limited, what I suggest for us is to buy a 4 terabyte external SSD that connects over USB-C or Thunderbolt. And those use the same connector. Thunderbolt is typically faster if you have the port for it, but it's also a lot more expensive. So I mostly buy the USB-C SSDs now, which are pretty good these days. I get mostly Samsung external SSDs. They go on sale often. They seem pretty reliable, and you can get them plain. They look like this, or you can get this more rugged version with the rubberized case if you're worried about dropping it. In 2025, I do not recommend getting a spinning hard disk drive for this part of the process. They're perfectly fine for long-term storage, but they're much, much slower for the calibration and stacking of your data compared to a solid-state drive, SSD. So to drive this home, this difference between a spinning hard disk drive and a solid-state drive, let me show you results from some real-world testing I did here using Serial and my Polaris Flare dataset, which has all calibration frames, 293 light frames, and I was running the OSC one-shot color pre-processing script. Here on the internal SSD on my MacBook, it took 4 minutes, 44 seconds to complete. An external SSD connected over USB-C on my MacBook took 6 minutes, 33 seconds. So still plenty fast, but a little bit slower than the internal SSD. And then the external spinning hard disk drive connected by USB 3 to my MacBook took 1 hour, 10 minutes, and 16 seconds. So roughly 10 times longer than the external SSD. So hopefully this makes it clear how important fast storage is to astrophotography processing speeds. Of course, no matter what kind of storage you have, the results in the end will be the same. The only difference I'm pointing out is how long it takes to get there. So now let's see what was generated by Serial in terms of intermediary data. Serial generated a little over 100 gigabytes of intermediary data with 11 gigabytes of raw data to start with. So what do I mean by intermediary data? Well, Serial puts it in a folder called process, and what it is it's copies of your files as they're being transformed into the final product. So there are your files after they were calibrated, and then after they were debayered, and then after they were registered, meaning aligned based on the star patterns. And all these different transformations of your files are necessary for pre-processing. That's what pre-processing is. But is it necessary to actually keep all of this? No, absolutely not. My preference is to keep all of the final stacks and all of my raw data that I captured, all my raw lights, bias, darks, and flats. I've occasionally thrown out the raw data and just kept the stacked masters. And if you're really short on space, you could do that. But I found that I actually often want to return to a project years later and process it from scratch with what I know now. And the best way to do that is to have all your original data, including the calibration frames. So I almost always delete all the intermediary files unless I'm sort of actively working on the project, but I always keep the original data and the stacked masters. And so now we're on to the final stage of the workflow, which is long-term storage. And this is the easiest one to maybe not spend enough time on, but it's important. And this is where having a NAS, a network attached storage, can be very useful. Before I invested in my first Synology disk station, I would have everything backed up on 2 external hard drives. And this will make me look a little crazy, but this is my collection of external hard drives dating back about 20 years. So a lot of this is copied, like 2 hard drives that are the same, but this is about 75 terabytes of data spread across 20 drives. And while with this system, I could almost always find any file I'm looking for eventually, I did have drives fail and I always had backups. It would just take frustratingly long to find things. So the overall solution to make this easier was a NAS. What this is it's multiple hard disk drives in one enclosure with a dedicated Linux computer that acts as a controller and a server. So you can actually access your data over your home network in a bunch of different ways. And I have mine set up on here in a way called RAID 6, where every file on here is mirrored in such a way that even if 2 of the hard drives fail, you still haven't lost any data, and you could go buy new hard drives to replace those. And if you get a Synology disk station like I got, I can assure you that it's really easy to set up and to maintain. It's been hassle-free for me since I got it 5 years ago. I'm sure there are horror stories out there, but I'm just telling you my personal experience. So when Synology contacted me and asked me to review this disk station, the DS1621 Plus, I was actually really excited because I was already a customer. I actually had this whole idea of talking about this in a big list of video ideas. So this is the perfect opportunity for me to make this video finally. So why does a NAS, a network attached storage device, solve a number of problems? Well, the biggest benefit for me is you add multiple drives, but on the computer, it shows up as a single drive with just a huge capacity. In the case of the 1621 Plus with RAID 6, 30 terabytes. And the reason I like having just one place on the computer for all my Astro data is it keeps things really simple. So it's much easier than having to just like sort through a bunch of various external drives, trying to remember the year that I took some particular thing and find it. So a NAS is very cool if you work with a lot of data over a long period of time like me. And there are a bunch of different options for Synology NAS devices. And my only real advice is choosing one that is in your budget, of course. And ideally, I'd make sure that you can expand it in the future if you need to store more data later, which you probably will. And so you have two options for expansion. You can either buy a NAS with more bays than you need to begin with and just add more hard drives to the empty bays as you need, or with many Synology DiskStation models, you can upgrade your NAS with an expansion unit, which just basically adds more bays, but in a separate enclosure. But it will still act as one big storage location when you access it over the network. But here's a question. If your data is just in one place now, not in multiple places, are we still following locks? Lots of copies keep stuff safe. And the answer is yes, but with caveats. Remember what I said about setting this up as a RAID system? RAID is an acronym. It stands for Redundant Array of Independent Disks. And a RAID can be set up many different ways, but I chose RAID 6 as it allows for 2 hard drives failures before you actually lose any data. And since all the drives are at the same age right now, I think it's a good idea because it's possible that 2 drives might fail right around at the same time. Now, it's very important to note that RAID is not a full backup solution. It's going to keep your data safer than just having it on a single hard drive with no backups, but you can absolutely permanently lose data even with a RAID system. Things can happen. The whole thing could fail for some reason, or let's say you had a house fire and this whole device burned up in the fire. If I didn't have copies of that data somewhere else physically, I'd be out of luck. So in addition to a RAID, it would be a good idea to have copies off-site, not in my house. That way, even if something happens here, my Astro data would still be safe off-site and I can recover it and make multiple copies again. That's the beauty of locks. So the easiest way to do this backup is probably with a cloud backup service like Backblaze. Now, if you're dead set against either paying someone to back up your data or you just don't trust the cloud for some reason, you could create a personal cloud. This gets a little bit more expensive, especially an upfront cost. But what you could do is you could get a second identical NAS, connect it up somewhere else, like let's say your parents' house. And then Synology has great software called Hyper Backup that will allow you to instantly back up anything on one Synology NAS connected to the internet to your offsite NAS. So that would be a much bigger initial investment because you're just doubling the cost, but it may be worth it if you're really against paying for the cloud backup, which would, of course, be on a subscription model. So now let's continue with the workflow and talk about how to set up a folder structure for long-term storage of your data so that it's easier to find things later. So here's how I have my folder structure set up. But I want to emphasize the important thing here is just finding a folder and file naming structure that makes sense to you and sticking to it. So mine goes at the top level, the first level of folders, we have all the object names for all the different astrophotography objects. And I just use whichever catalog comes to mind when I think of an object. So if an object is listed in multiple catalogs, I just pick the one that I know it best by. My second level is year. And the reason I do that is if then I revisit an object like I did here with SH2 129, the 2 attempts that I've made on that object aren't mixed up. So I have 2024 and I have 2017. The third level of the folder structure has a number of folders, a folder holding all my raw data straight from my image acquisition software. And in there, it's organized by date. A simple text file with some info about the project. You can get this from your Astro bin. And then I have one folder for each processing attempt I made. And inside the processing folders are anything I think is worth keeping and may want to return to. And I'll usually have a Photoshop document in there as I finish my photos in Photoshop. And then if a project is good enough that I've also made prints, I'll also have a print folder at this third level, as I found that I often want to reprint something. And if I've already figured out the print adjustments for a particular paper that I use, it's nice to save that work and have it handy so I don't have to sort of replicate my work again. So this whole folder structure is what goes on my NAS for long-term storage. And you may be thinking, so you just went through the whole workflow. Why there's so many steps? Why transfer the data from a capture computer to an external SSD for processing and then finally to a NAS for long-term storage? Do we really have to make all those steps? And of course, like anything, it depends. If you get a NAS and you put it in something like RAID 6, make no upgrades, attach it to your router over 1 gigabyte, access it over Wi-Fi, that's not like an SSD. You're not going to be able to process your data directly on the NAS. When I did a speed test, I was getting 17 megabyte write speed to the NAS and faster read speed, like 60 megabytes, but still that's not even as fast as an external spinning disk hard drive attached directly to the computer, and much, much slower than an SSD. So I was interested in all of this. I'll just go through this story quickly. I went ahead and I doubled the RAM on my NAS here, got a 10 gig network upgrade card, both of which are incredibly easy to install. After making those upgrades, I connected the NAS directly to my MacBook through a 10 gig Ethernet to Thunderbolt adapter. And with this setup, I was getting 700 megabytes per second write speed and over 1 gigabyte per second read speed. And so that's actually in the same ballpark as an external SSD. And definitely should be fast enough for astrophotography pre-processing. Unfortunately, when I actually tested running like the Zero pre-processing script directly on the NAS with the 10 gig setup, it would always eventually have some kind of error and not complete the pre-processing. It would always have that error before it completed the whole shebang. It would sometimes get like halfway through, sometimes 3/4 of the way through, but it was always error out. So I'm a bit confused by what I'm doing wrong or if I'm doing anything wrong, because I've seen in other people's videos using similar setups to this, people working directly with video footage on a NAS in a video editing program. And I don't really see why that would work, but astrophotography processing would not work. So if anyone has any experience with this kind of stuff and has any ideas, let me know. But in any case, not really important to the video. Just thought I'd mention it here towards the end, as it's something else I tested. But the point of all of that was probably the reason for all the steps is different kinds of storage devices serve different purposes. And your capture device may not have enough room for processing all your astrophotography data. You might want the fast SSD for the speed and processing it. Then once you've done the processing, you move that what you need to the long-term storage, and you can then wipe the SSD and have it ready for the next project, while everything that you want is stored on your slower long-term storage, whether it's a NAS or just an external hard drive or the cloud or a combination of those things. Okay, so I'm sure this was a long video. I feel like I've been talking a while on storage and data management, but what is this all in service of? Well, in my case, it's to share my love of astrophotography, and a wonderful partner in that is Squarespace. Squarespace makes it easy to set up and run your own personal website with your own domain name. And so my Squarespace website is at nicocarver.com, just my name. And when you set it up, you'll have many different easy to use options for the design of your site. Mine is fairly simple, but I think elegant. It's a portfolio site for my astrophotography. And if you ever want to change the design, Squarespace has an excellent design system called Squarespace Blueprint. And that makes it really easy to change the design to your liking. I also like that so much is built in, including a spam-free contact form and tons of tools for selling products and services. I haven't turned that on yet, but I have looked through it, and it's nice to know that if I ever want to sell prints or consulting or whatever through my website, that's going to be really easy to turn on and set up, and customers then can pay however convenient is to them, whether it's PayPal, credit card, or Afterpay. So If you need a website and you want to try this out, head to squarespace.com/Nebula Photos for a completely free trial. And then if you're ready to make a first-time purchase of hosting or a domain, use code Nebula Photos at checkout for 10% off. And since this video is over 20 minutes long, you're now seeing the names of everyone who supports this channel on patreon.com/Nebula Photos. I can't thank everyone you're seeing here enough for their support, because between sponsors like Squarespace and ads that run on the YouTube videos and then the support on Patreon, that's the most important part, I'm able to run Nebula Photos full time as a solo creator, and that's been a blast. I've been doing it for 2 years. And if you do join over on Patreon, there are a number of perks, of course, that I've split into different tiers that you can check out. But everyone, even at the $1 a month level, gets direct messaging support with me, a monthly Zoom call, access to the Patreon channels on my Discord, and some exclusive content once in a while. And also in-person meetups, all kinds of different stuff. So check it out, patreon.com/Nebula Photos. Till next time, this has been Nico Carver. Thank you so much for watching. Clear skies.